Since I won't be here for flex, I want to get you at least started on the two application problems. 54 isn't too bad, 55 is quite interesting. So looking at 54, there's a ton of flavor text here about mirrors trying to give you this visual of what's going on. But as far as what they want, find a model for a hyperbola if conjugate axis is 50 and the transverse axis is 30. Both of those units, centimeters. They don't specify what kind of parabola, whether this is horizontal or vertical, so you get to pick. That's quite nice. So I'm going to go ahead and say the transverse axis runs this way, and the conjugate axis runs this way. Keep in mind, if you were a good artist, those would be perpendicular and they would meet in the center. So start there. Here's your tool tip. If you know the whole conjugate axis is 50, how much is this part? Oh, by the way, that's B. And if the whole transverse axis is 30, how much is this part? Oh, by the way, that's A. So hopefully that's enough to get you set up there. 54 is not too bad. 55 is another story. A lot of flavor text here again. Hey, the FAA performs flight tests, yada yada. One of the test craft is collecting data. It was 18 kilometers farther from airport A than airport B than airport A. In other words, we're closer to A than B. The two airports, they give us a distance of how far apart they are, and then they also give us an orientation, a north-south orientation. So let's go ahead and sketch that. I have an airport A and an airport B. I know how far away those two airports are, and at first glance, it's not totally sure. We're not totally sure, like, where's the hyperbola at here? It's actually hidden right here, 18 kilometers further from one airport than another one. Keep in mind, that's the definition of a hyperbola. The difference between two distances is always constant. So there are an infinite number of points that are 18 units closer to A than B. So that plane could be there, or there, or there, or there, or there. That's where the hyperbola comes from, being 18 kilometers closer to one than the other. Again, that 18 is a difference, the distance from one minus the distance from another. So let's try to whittle this down a little bit, because thinking about an infinite number of points is spooky. So we know A, we know B, we know their total distance is 72. Those are the foci of our hyperbola. So right in between them, they do tell us, by the way, to make that point the origin. Sorry, it took me a second. That is an A, centered at the origin. So that's going to help you with your model. That X there that I'm calling the center, that is the origin. So we can also get that this is 36. It's half of 72 from the center to that focus is 36. So we can start, labeling some coordinate pairs on all the stuff that we know. But that still doesn't help us get our A and our B values just yet. We have our C values, and that's great, but we don't yet have A and B. So one thing to help us out is to try to reason through this and say, well, that airplane is an infinite number of places it could be, but one of those places is the vertex of this hyperbola. That plane definitely could be at that vertex, and that is very helpful, because that definition still applies. That airplane is a certain distance away from airport A, but regardless of how far away it is from airport A versus airport B, we know that the difference between those two distances is 18. That's in our given. But we also know that the sum of those two distances is 72. So we haven't had to deal with systems of equations in a while, and keep in mind, if you jump into the back of the textbook, you look at the solution manual, they don't use a system of equations to set it up. There's always more than one way to do everything. What I like about this method is it's a bit more visual than the solution manual version. Note that just by graphing, like the graphing we did previously, I was able to set up this little system. That doesn't make it an easy problem, but it's one that we get to visualize a bit nicer. Solving this system, hey, the D's cancel. So double the big distance is going to be, what, 90? Divide both sides by 2, and that gives you a distance of 45. So we know now the distance between a focus and the far vertex. And we also know the distance between that vertex and each, that vertex and A. In this case, it would be 72 take away 45. And 72 take away 45 is 27. That 27, that is this distance. That can then help us find our A value. A, again, is the distance from the center to a vertex. From the center to the focus was 36. So we can do 36, take away 27, and that gets us our A value, which is one of the big pieces of information that we need in order to write that model, to write an equation. So again, take a look at the solution manual if you like. Note that they find that same value of 9 for A. They do find it quicker, but they find it using a method of formula memorization that I don't think is nearly as helpful as having a nice visual. So check them both out, see which one helps you out the most. Try to do the rest from here on your own, see where you get. Once you have A, you already know H and K. C is up there already, you can probably find B. Once you have A, this problem wraps itself up pretty nicely. So give it a shot, let me know how you're feeling, and have a great weekend.